Power to the Truth. This is Margo. This is Tuesday, August 28th, 2018. And today I'm going to be reporting on a video that Robert Scribbler or Robert Fanney put up today, and Robin Westenra did a blog post on it, and now this is my video on it, and it's two Arctic cyclones that are forming that are going to be hitting the Arctic by the end of this week, by August 31st. So we have Earth Null School pulled up here, and I'm going to be coming back and forth to this between different articles that I'm going to share with you today. But this is August 31st, and this is the wind temperature, the wind speed at surface level. And what we're looking at, here's Greenland, here's the Arctic, and let me move this green dot, and we're seeing a circling motion here above Greenland, and so that's one of the storms, and another one coming off of East Siberia and down into the Beaufort Sea and then back up and around. So we're going to be coming back and forth to this. So I'll just go back a day at a time so that you can see how we got here. Here we are on today, and we can see that there is some circling down here off the east coast of Greenland, and there's been an Arctic storm up here just going around in the Arctic. But I'm going to zoom in now, and it just goes from way far out to way close in. So then what happens is, here's the 29th, and we can see this developing more. This storm here is moving down, and then we've got more coming off of Siberia, and then we've got more coming up from the Atlantic. And then if we move forward another day to the 30th, we can really see this circling developing here off the northeast coast of Greenland and just to the west of Svalbard. And these winds are getting up there for the winds in the Arctic at this time of year, and because that's at 47 kilometers per hour. And then when we get to the 31st, here we have the large circling of the wind here on this right side, and then a large circling on the left side, which is off of the East Siberia Sea. And the wind speed here is 72 kilometers per hour. And in case you don't know what that is in miles per hour, I've got a conversion thing. That's 44 miles per hour. And that's quite high for the Arctic. And let's see what the wind speed is over here. That one is 44 kilometers per hour. So that one's a little bit slower, but so it's 27 miles per hour. So it's a little slower, but it's still going. So we're going to leave that up. And now I'm going to go to Robin's blog and read that. And then we're going to hit a couple of other websites, and then I'm going to show you the sea ice from today. So it's going to be a medium-sized show. So this is Robin's blog post. It's dated Wednesday, August 29th, because he's in New Zealand and he's already into the next day. But it's the 28th for us over here in the U.S. 2 large cyclones to hit the Arctic in coming days. I borrowed the very good headline from the Great White Con, the Great Arctic Cyclone of 2018, ? Both Robert Fanney and the Great White Con are reporting on a couple of cyclones that are predicted to hit the Arctic in the next couple of days. This is how it looks. And this is Robin's view of the Arctic. This is how it looks right now. Now his is a little different because he has Greenland down here, but you can see that's the storm that's been going around in the Arctic for the last few days. By the 31st, forecasts have 2 cyclones hitting East Siberia and the east of Greenland. It's actually, from where I got it, it's to the east. It's kind of to the northeast of Greenland and north of Svalbard. So, and there's his picture on the 31st. And there is something happening at the base of Greenland. So, we can, let's pull this up. There's something going on down here, off the southeast part of Greenland. Here's another system, but and it, it could be feeding into this other one up here. So we've got several systems going on here, is what it looks like. So we'll move on. In his analysis of the Null School forecast, we are likely to see the storm go down as low as 968 millibars. By comparison, the Great Arctic Cyclone of 2012 saw air pressures fall to 966 millibars. It also forecasts waves of 7 to 10 feet, going up to 12 to 14 feet in the Beaufort Sea. And this is from this is a screenshot from Robert Fanney's video that he did, where he's showing the millibars, and you can switch that on Earth Null School. I'm just now learning it. I haven't really used it that much before, but you can switch that down here, and then it turns to mean sea level pressure. And I don't really know how to read all that yet. I just stay with the winds and easy stuff. So I don't know what that means because I haven't studied it that long. So I'm going to go back to winds. Well, oh, winds down here. And then here's screenshot of Robert's video that he did today on it, and I'll leave a link below to all of these things that I'm referring to. I'll leave a link to Robert Fanney's video. It was quite good. And I'll leave a link to Robin Westenra's blog and a couple of other things too. And here's the article from the Great White Con. That's another really good website that talks about the Arctic. The Great Arctic Cyclone of 2018, ? Our title for today refers back to the Great Arctic Cyclone of August 2012. There has been some speculation over on the Arctic Sea Ice blog about whether a similar event is about to occur this year. It's later in the season, of course, but as is our wont, we always look at the waves first. Here is the current Wave Watch 3 forecast for the evening of August 31st UTC time. So I don't know where this is GPIB forecast or observation time. I haven't used that before. And so this is the wave heights that they're predicting, and we can see that it's up into the red zone, which is 6.5, about 6.5 to 7 feet, and then here's 8, where it gets into the dark red. And here's Svalbard here. This is the sea ice here, and Greenland is down here. It looks like a computer model. Here's Novaya Zemlya over here, so you get a reference point. Mean period of swell waves, and we can see that they're going to go up quite high, up to, they're predicting up to maybe 15 feet in the wave height down here, and then waves over here, and then that's going to be affecting all the sea ice. So in summary, the forecast shows some very large waves with a substantial period for inside the Arctic Circle directed straight at the ice edge. Let's follow the forecast over the next 2 days carefully, shall we? And then Robin puts a link to Robert Fanney's video. And then he says, here for comparison is the Arctic Cyclone from 2012 that wreaked havoc on the sea ice. And this is a video that Paul Beckwith did in 2013. It was very good. He says, however, I hardly need to point out the fragile nature of the sea ice. It's ready to go, and if forecasts are correct, this just may provide the coup de grace. So, there's that article from Robin at Seymour Rocks. So here's Earth Null School again, and so we're looking at this area here above Svalbard, and the sea ice comes out, I'm thinking 87. Well, we'll take a look at NASA Worldview and see how far out that sea ice comes, and see if it's like over the ice or next to the ice or where, because we can get longitude and latitude here. So I've got Worldview pulled up here. This is from today. You can see that it is quite cloudy because of all the storms that are gathering and doing stuff. So here's the ice edge here. I'm going to zoom in a little bit. So what they're talking about, the storm on the 31st, is up here, right up here, circling around, and it's going to come over to 87. Now that's 85. That's 87. So it's going to be covering the Arctic sea ice. It's going to be coming around and around. Let's see how big, you know, how far north this wind is going to come in from. Okay, that's 78. So it's going to come in 78. Here's 82. 78, 80. 78. Okay, so it's going to be coming, it's going to be quite large. It's going to be coming around like this, about in the 87 range, and then back around. So there's a lot of sea ice right here that's going to be affecting. So that's pretty wind covered today, cloud covered today, so we can't really get a good view of what that sea ice looks like. Let's look at yesterday and see what we can see. If we can see the condition of the sea ice at all. We're going to have to look through some clouds. It's broken up. You see this here? That's even looking through some clouds. It's quite broken up. And I found some things from yesterday that even though there's a lot of cloud cover, there are areas that where you can peek through the clouds and look at the ice. Like, let's see. Well, for our purposes today, what is that? 83 and 28. That's not really an area that's affected by the cyclone. I'm gonna try and get that for you today. Well, let's see. Okay, here it is from today. We have some open areas, but the clouds are coming like right over the edge. But the ice, I'm telling you, the ice is really broken up. You can see as we get further south here, where there are fewer clouds to have to look through, you can see this is the ice. This brown color is clouds. So this white color is ice. That's all ice. And here's Greenland. And here's that Cape Morris Jesup. So we can see that that's still broken up. It's really broken up still. And there are large areas. You can see through the clouds how the ice is deteriorating, and there are areas with a lot of water between the ice pieces. You just can't see it very well because of all these clouds. So let's go up to this East Siberia part now, where this storm is going to be. And let's look at that. So it's going to be coming around the north part of Alaska off of Barrow and then up, and part of it will go down into the Beaufort Sea down there. All of this is the Beaufort Sea, and then it's going to circle back up and come back around. So I'm thinking that area is pretty ice-free right now. Just depends on how far around it comes over to the east, because we do have some remaining ice right along here. You can't see it because of the clouds again. Here we can kind of see it through this picture. Here's the ice edge on the western side, and it's quite fragile and quite thin and quite broken up, as you can see. And we're looking through clouds, so you can't even really get a good picture of the ice right there. Let's see what it looked like. Okay, here's a better picture on the 26th, where we can see the ice and its integrity, and it just looks like lace. That's what the ice looks like up there. Uh-oh. Hang on. Here we go. So, let's get some coordinates so we can see where we're coming from. Okay, this, where it's going to be the strongest, is going to be at 74 north and 152 west. So it's 74 north is about there, and 152 west. It's going to go more to the left. So down here, actually, the measurements are not the same. The longitude and latitude are not the same on NASA Worldview, because that's, maybe it's in this little cubby hole. Because that's 165 west. 152 west is way over here on land. So that's what it says. You know, I've been hearing about the pole shifting, so maybe NASA has updated their longitude and latitude according to the pole shifting slightly, and maybe Earth Null School hasn't. I don't know, but that does not match up with NASA Worldview at all. Not at all. So anyway, from the picture, it looks like it's coming down and around here, coming off of the Siberia Sea and coming down off of the coast of Alaska. Here's Barrow and this little tippy point, and then coming down and around and coming up. So that will be affecting this little itty bitty part of sea ice here on the left, right above Alaska, and this sea ice over here. And of course, with the winds and the waves and everything, it's going to go, the ripple effect, it's going to go way out, and so it's going to affect all of this sea ice, and it is not in good shape. You can see through the clouds how it's broken up so much. This is 80 north latitude. And the same thing over here off of Svalbard, and it's going to be coming around and over and chewing up all this ice. And if it's warm enough, you know, it's going to be dumping rain, and then that's going to be, you know, that's not a good thing. That's going to make that ice melt. So it's just going to chew it up and spit it out, I think. So I wanted to show you something else. Not from here. From yesterday. From these small areas where it's cloud free, where these colors are, where it's cloud free, we can zoom in and get a look at the ice. And now there's a little bit of cloud cover here, but we can really see, look at how much open water is developing between the ice here. And this is that part north of Greenland. Then here's a trail between the clouds where we can see. Here's another place of open water. I mean, no clouds. Here's another one, no clouds. So this is the integrity of the sea surface as we're coming into these two cyclones. And you can just assume that a lot of this sea ice is really broken up with a lot of water between it, and we just can't see it because of the clouds. Look over here. See that? This used to be part of that old multi-year ice that has gone away. It's gone. And we got big problems coming up. There's a big hole there. So I was just looking, and every day the ice is different depending on what the clouds look like, and you know, how much is melted or what's frozen back and things like that. Here's the edge. Actually, that's clouds, because I know that edge is pretty straight right now. And here it is from today. And like I showed you, it's mostly cloud covered. But that cyclone on the east side, it's going to be hitting this area. So let's look at the areas that we can see. Oh yeah, see how cracked up that is? That's going to be chewed up with all that wind. And with the waves and the ocean sloshing around and everything. So I'll be watching this and reporting for everyone. Look at this. We're looking through a few clouds here, but you can see the sea ice. Really broken up. Huge area that's cloud free where you can really get a good look. So that's what it looks like. Here's another area up here where we can kind of zoom in. We're looking through clouds there. That's hard to see. And so forth. And there's one more article that I want to share. But before we do that, I have the Navy website pulled up. Here is the sea ice thickness from today. And so where those cyclones are going to be coming in are right around here, circling right around here, and over here, and back up and around. So this is quite a large area, and to have two at once like this is going to be significant. So I expect with these cyclones, that this one on the west side from the East Siberia Sea, I expect it to take out probably most of this ice, and it's deteriorating very quickly anyway, and then it will deteriorate even further, this ice edge here, and it could even have an effect on the ice down here. And then the one on the east side, it's going to chew up this ice here. So, you know, we just thought we were out of the woods. We're not out of the woods. Anything can happen because we're in no man's land. Now this is what the Navy was expecting as far as the sea ice thickness for a 30-day period and going into the next 7 days, but I don't know if they were considering the cyclones coming in. I really don't know. So there's that. And then there's one more article I want to share, and then we'll wrap it up. I found this article from Weather Underground, and it's a blog post. I need a drink of water. Hang on. Called The Great Arctic Cyclone of 2016. After 4 years, a summer sequel. So the other articles were referring to the cyclone of 2012, because that's when we saw such a loss of sea ice. This is by Bob Henson from August 16th, 2016. As of Tuesday, the deepest cyclone in the northern hemisphere wasn't anywhere near the tropics. It was spinning in the central Arctic Ocean, a surface low located near 83 degrees north, about 500 miles from the North Pole and about 1,000 miles north of Barrow, Alaska, deepened to a central pressure of 968 millibars at 2 a.m. Eastern Time, Tuesday morning. August 16th. This is on par with the central pressure you might find in a moderately sized Category 2 hurricane. Such lows are a common feature of Arctic climate, but they rarely gain such intensity in the middle of summer. The only deeper Arctic cyclone on record in August is the Great Arctic Cyclone, or GAC, of 2012. According to a 2012 study by Ian Simmons and Irina Rudeva from the University of Melbourne, this low bottomed out at 966 millibars on August the 6th, yielding the lowest pressure analyzed across more than 1,600 August cyclones in the Arctic since 1979. The cyclone's minimum pressure was even lower, 963 millibars, in the real-time analyses produced by Environment Canada while the storm was raging. So this is big. This is big, because the two coming in are going to be around the same millibars. So here's what it looked like for the Arctic cyclone in 2016, and it looks like it was right around the pole. So they only had one going on, and now we're going to have two. So who knows what's going to happen? Seriously. Okay, wind, waves, and ice. The GAC, or Great Arctic Cyclone, of 2012 churned across the Arctic for 10 days while its central pressure was below 1,000 millibars. The cyclone had major effects on the distribution of regional ice and appears to have played at least some role in that summer's record depletion of Arctic sea ice. Normally, low pressure near the North Pole causes ice to spread out as surface waters and sea ice move to the right of the surface wind. Yet, the intensity and duration of the 2012 cyclone's winds and waves appears to have more than compensated for that effect, leading to an overall loss of ice extent. Okay, I'm just going to interject. So if we have the ice spreading out, then that means it's going away because it's so thin anyway. The extent plummeted in August 2012 en route to a record low extent in September. And remember, extent is different than thickness. A study in 2013 led by Jinlun Zhang, University of Washington, found that the GAC quadrupled the melting of sea ice from below by pushing warm surface water against the bottom of wind and wave-tossed ice flows. However, because much of the Arctic ice was already thin and compromised, much of the extent loss that would occur in August and September was already baked into the system when the cyclone came along. Zhang and colleagues estimated from a model simulation that the record September minimum was only about 4% lower as a result of the GAC of 2012. And then he talks about the cyclone of 2016. It's too hard to know right now, you know, how it's going to affect the extent and this and that. And so on and so forth. So that's what it looked like in the 2016 cyclone. That was August 16th. So we're a little bit later in the season than that. This is August 28th, so we're a little bit later. We're 12 days later than the one in 2016. And here's the sea ice concentration before the cyclone. And so on and so forth. Here's potential impacts. As of early August, the Arctic sea ice extent was among the 4 lowest on record. Well, guess what? I just did a show yesterday saying our ice extent is among the 5th lowest on record. Since satellite monitoring began in 1979, temperatures across the Arctic for the year thus have been far above record levels, and we've seen that this year too, and etc., etc. He said we can expect some dramatic changes over the next few days as winds and waves break up ice and churn up relatively warm water from below. Much will depend on the exact track of the Arctic cyclone and how long it persists as an intense low. Well, that can be said. The same thing can be said for these 2 cyclones. Will climate change lead to more great Arctic cyclones? Given the amount of change occurring to the state of summer sea ice in the Arctic, it's natural to wonder if there might be a change in the upward pointing influence on atmospheric circulation. An interesting question is whether the long-term loss of ice and increased heat and moisture fluxes is making Arctic cyclones more intense, Screen noted. The jury is still out on that one, but if that was the case, we could expect GAC-type events to occur more frequently. A 2000-year modeling study led by Yvonne Orsolini, Norwegian Institute for Air Research, estimated that the number and strength of summertime Arctic cyclones would increase slightly through the 21st century. Over the long term, we do expect a lowering of the mean sea level pressure over the Arctic with sea ice loss, says climate modeler Clara Desser, National Center for Atmospheric Research. To the extent that this signal reflects cyclone behavior, I would concur that under climate change, it might be the case that cyclones would intensify. However, attribution of the extent to which the Great Arctic Cyclone of 2016 is a result of the loss of sea ice is more challenging, since internal variability may also contribute. And then they leave some links below. So there's that article that I found quite interesting, and I wanted to show something else. You know, they focus on the pressure, sea level pressure, but you know, I like to look at the winds, because the winds show, you know, how the ocean is going to be turning around and around. But anyway, so we'll leave you with this picture from Earth Null School with our 2 developing Arctic cyclones. So stay tuned. We've got exciting stuff happening. Things are heating up in the Arctic. We just had a little lull there, so things are heating up, and we'll keep reporting on this. Until next time, my name is Margo. My website is margoshealingcorner.com. And everyone go in peace, God bless, and goodbye.